I'll be going over some Python things for you guys. And so mostly since a lot of teachers, of course, nowadays use Python as the programming language to teach their students to program, we also get a lot of requests on how to best create automatic grading for Python assignments. And in this focus group, I would like to go over some ways to do that, not only for Python, also for Jupyter Notebook. I'd like to start with just vanilla Python. First, an introduction to Python example course assignment that just uses our input-output tests. And after that, I'll go together with you guys, create a Python assignment from scratch, where we'll start with these input-output tests, then add a code quality test to check for PEP 8 style, and then finally add some unit tests using the built-in Pytest. After that, I would like to tell you guys a bit more about Jupyter Notebooks. So as you know, Jupyter Notebooks is a way of using Python as well, combined with LaTeX and Markdown. And they're actually a really good way of teaching Python. It's also really intuitive to use them inside CodeGrade. What I'll show you is how to run a Jupyter Notebook inside CodeGrade, how you can autograde one with simple input-output tests. And I'll tell you a little bit about a Jupyter unit testing framework we're building in-house that you can join a closed beta of. Finally, I'll finish with some advanced stuff really quickly. First of all, detecting structures in Python code. You can think of, let's say, an introductory to Python course where you want students to use a for loop and not a while loop. We actually found a way to do that really easily. We wrote a blog about this, so maybe some of you have already seen it. I'll quickly cover it in this workshop as well. And then last but not least, I'll show you how you can import a Jupyter Notebook or another Python script without printing, which is very useful, of course, if you want to use input-output tests using the Python interpreter. So things that the student prints will not interfere with the output that you're expecting. So let's get started with simple Python. And for this, I have an example assignment, which is a very easy Fibonacci assignment that we create on two parts. First is the basic functionality. So given an input, a number, you should output the number of items in the list of the Fibonacci. The first rubric category assesses that, and you can get between 0 and 7 points. And then we also have a bonus rubric category where we check if the program does not crash when given a non-digit input or when given a 0 as input, as of course, 0 can cause a crash as well if you're expecting more than one list item or one or more. So let me show you what this looks like inside CodeGrade. I have the assignment set up right here and actually handed it in. So we can see it's a really easy small Python assignment. And if we go to the auto test here, we can see that we have some basic functionality tests. So again, these tests will fill in this rubric category, and these tests will fill in this rubric category. And we can see that we, given 1, then we just have the expected output of 0. Here we say a short sequence, so we give the input of 5, and then we expect 0, 1, 1, 2, 3. And that's exactly what we get as well. And here a longer input as well. Now for the bonus, what we do is we give as input not a number, and we expect it not to crash, and it doesn't crash, and it says, please input a positive number. So this works as well. Finally, we input a 0, and it doesn't crash as well. So this is just a really easy example of input-output testing. And let's do it ourselves now as well. And for the rest of this Python part, what I want to do is create a Python Sudoku solver automatically graded assignment with you. And this Python Sudoku solver has some requirements. So we tell the students a couple of functions they have to implement. And basically how it should work is when you run the Python Sudoku solver with Python sudoku.py, then given as standard input this string, then we expect as standard output the solution. So in this case, the underscore means a empty cell, and we want to fill those empty cells with the correct answer. So let me start setting up that assignment with you. And I I should have an empty assignment here. Great. So to start off, let me copy a rubric from a previous assignment. So we already have the rubric in place here, and we just have to fill in the tests for the rubric categories. And what I can do now is create another test. And since we want to start with these simple input-output tests, we don't need to do anything of the setup, as Python is installed by default in Autotest. So we can right away add a level, add a category, and we can select the functionality of the Sudoku solver. And we can start creating our input-output test. So do you correctly Sudoku? And the program we want to test, of course, is Python 3 sudoku.py. And later on, we'll enforce the students to hand in sudoku.py with the handing requirements. So let me give first a simple 4x4. And what we will do, I actually have some input and output files ready here. So as the example in the slides, given this input, we want this output to come out. What we can do now is we can make it a substring match. And that's really convenient, since most of the time students will maybe say something like solution is, and then as long as our expected output, what we write here, is a substring of their solution, it will be correct. And let's ignore all white space, since we don't really care if they print it like this or if they print it like this. So let me add a new medium input. And let me copy and paste the input and the expected output. And I have one more pair, which is the hard input. And just copy and paste some input and output. So this is again the input we give via the standard input. And this is the output we expect via the standard output. So let me save this. And having that, we can now start the auto test. And this is a really good practice to always iteratively test your auto test. So to do that, what we can do is we can go to the general tab here, and we can scroll down here to upload submission. Even if the rest of your assignment is not set up, like the deadline, we can upload a test submission. So we check the test submission option here, and we can select a solution. So let me upload the sudoku.py and upload this. And now what I'll create as well really quickly is the hand-in requirement here, where we tell the students that they have to hand in sudoku.py in the root directory. Save, submit. All right, so now we can go back to this, the auto test, refresh it. As we can see now, we can check if what we just created works. So given our example solution that it is running on now, the test student, we can see if the tests that we've created work. So as we can see, all of the tests work. We get the 100% score of the functionality of the Sudoku solver category. And we can see that given this expected output, the actual output was correct. So as you can see, creating these input-output tests for most of your basic Python assignments is really easy. Now we can add some different things to this assignment as well. And the next thing I want to add, and Youri, please interrupt me if there is questions in the chat. But if not, I'll keep going. No. Great. So the next thing I want to add is a code quality check. And we use the Flake 8 linter for that. But we also have PyLint. And if you want, you can also use another Python linter. And what we do with this Flake 8 linter is that we check for the PEP 8 style guide, which is a very common Python style guide that we tell our students to conform to. And with this code quality step, every time they upload, automatically they'll get feedback on their code quality as well. So to add this inside CodeGrade is actually really easy. Let me stop the auto test again. I'll create a new category for that. Go up here to the select rubric category and select code quality, since that's the rubric that we created. And now we can add a code quality step to this. And let's call this, does your code conform to PEP 8? And we can select one of the linters from this list. And as I said, Flake 8 and PyLint are for Python. But if you are using Java or JavaScript, then we have check style, PMD, and ESLint as well. And using the custom option, you can select your own linter that you want to use. So if we want to use Flake 8, again, since it's a very basic Python assignment, we don't have to add anything else to this. This will all work out of the box. We don't need any configuration file. Of course, you can add it if you want. We don't need extra arguments. Of course, you can add them if you want as well. I would say, but it's turned on by default, ignore unknown files. So let's say you generate files or you compile files or you add fixtures to this. Having this set to yes will make sure that these files are not crashing your Flake 8 linter. Then we can set the penalties for the different levels of messages that we get. So by default, there's these 4 levels, fatal, error, and warning. So if they have a fatal message, I want to give a 50% point penalty. For a error, a 5% point penalty, a warning 2, and you know what, warning 1, and this 0% since it's just an info. So let me save this and show you what this looks like now. And what's nice is that since we already have uploaded the test student submission, we can now simply just start the auto test again. And right away, it will start running on the test submission, but also all the previous submissions. So with this workflow, it's really easy to iterate over your auto test, and every new category or step that you add, confirm with your example solution, because right away you can just press start and see if it works. So let me wait for this to work. As we can see, it's already running. These all pass. And this one will run as well. All right, as we can see, we get a partial point for this. So we get 0.2 out of 1. So that means, and as you can see, we have a couple of mistakes in our code. So what's nice about this is that we can click on these as well, which takes us to the code that we've handed in. And if you use the code quality step inside CodeGrade, you will get messages inside your code as well, all automatic. And as you can see right here, hovering over this message will also tell you what this message is about. So this is a very useful one. We import the OS package, but we don't use it. For instance, this is also a very useful one. We use the ambiguous variable name L, and it's of course a good practice to use a better, more clear variable name. So as you can see, there's a lot of messages in here, which explains our poor grade. But this is a really good way for students to find out how or which mistakes they make, and a way for them to improve them, because they can of course hand it again and see if they improve their score. So let me go back to the auto test here, and I'll go back to the slides. One tip I want to give you guys. So as we can see, there were a lot of different messages, and it could be that for your specific assignment, some messages are not applicable. For instance, maybe we don't want to check for packages that are not used or not for ambiguous variable names. You can find a list of the error codes of these messages on the Flake 8 documentation page, for instance, and you can use the ignore flag like this to ignore specific packages or specific messages for your linter. Of course, you can also configure this using a config file, but if it's just a couple of messages that you do not want to check for, you can ignore those rules using this extra argument right here. All right, so let's get on with the unit testing. So next to the IO test that we have, we also want to test some specific functions that we told our students to make. So in this case, we have some input functions that we want to test, and we also have the get cell and the set cell functions. So we want to do that, of course, using unit tests. And one of the unit testing frameworks that you can use for Python is, of course, Pytest. And CodeGrade supports Pytest out of the box. We use the CG Pytest wrapper script for that, which is installed, or it's not installed, but it is on the auto test image by default. And let me just guide you through how you can set that up. So first of all, we upload our unit tests as fixtures. So let me stop this. And let me upload our fixtures here. So as you can see, submit. Don't forget to press that. And we can see the Pytest unit tests that I've created are uploaded now. Still using the old UI. This will look way better in our new update. So that's step 1. Now, step 2 is to install CG Pytest. So it is on the image by default, but of course we have to install it. So what we do for that is in the global setup script, we install CG Pytest, install, really straightforward. And if you use another unit test framework, all of these steps will be somewhat similar, but you can find documentation on that on help.codegrade.com. So having that installed right there. One more thing I want to mention here is that, of course, we have the global setup script and the per student setup script. And the global setup script will set up the whole environment. So this is where you want to do these installation steps. Per student setup script is where you configure the student environment. So this is where you already have the student code, and this is done on a per student basis. So doing the installation in the per student setup script will of course be less quick, since you have to do it for every student again. Whereas here you do it one time in the beginning and it will be available to all the students. What you can do though in the per student setup script is copy things over to the student folder. So for instance, what we can do now is for the test Sudoku file, move it to the current directory, the student folder. So we move it from the fixtures folder. So everything that you upload as a fixture is in the folder $ fixtures. And let me find that Sudoku. And we move it to the current directory or the student folder. So the student folder you can access by $student, but this could also be the current directory just with a point, with a dot. So it's up to you. Using student is a little bit more clean, I guess. So don't forget to submit both of these. That's a common mistake, even still with me. And
will be fixed as well. So if you didn't make any changes, then it will stay grayed out in the next release.
Great. That's a good fix. So after we've created this and we have copied and installed the unit tests and installed CG Pytest, we can now create the unit test step. So let me just add a new category again for that. Use the unit test category, and I can type in run the unit tests. And what we do here, that is really easy, is type in CG Pytest, which is what we just installed. Again, if you use another unit testing framework, that's where you change that. We say run, and then we specify our tests. In this case, test Sudoku .py. So now, since we moved the test Sudoku to the current directory, we can call them directly like this. But of course, if you did not do that in the per student setup script, we can still access them in the fixtures folder right here. Let me save this. Of course, I have to select the rubric category, the unit test one. Save this, and now we can start it up again to see if our new addition to our auto test is correct. Maybe a good time, Youri. Are there any questions you want to share with everyone?
No questions so far.
Great. Needed something to fill the time here, but there's nothing. Well, yeah. So
actually, to fill the time, for Pytest, you don't have to actually move the script to the student directory. For other unit testing frameworks, this is sometimes a requirement. So if you're using JUnit for Java, then you actually have to move it, because otherwise it can't find the Java files. But Python works a little bit different.
Yeah.
In that regard.
So the difference is, of course, that Java is a compiled language, so you have to use the unit tests to compile. Right.
Exactly.
Yes.
So question, can this setup be done via a script, or do we have to go via the GUI to set up tests? So you can also do it via a script. So either just like upload it and then call that in the user interface. What we also see people sometimes do is use the API to actually set up the whole auto test. And we have some scripts available for that as well. So definitely send me an email and I can help you with that. Maybe a good idea for a blog at some point as well to do that. So you can fully set up Autotest without using the user interface.
Yeah, definitely. Good idea and good question. However, I guess the easiest way is to just do it like this. So as we can see, thanks for filling the time, Youri, the person who asked the question. The unit tests have been run, and what's nice about this as well is that automatically it will extract all the individual unit tests that you have defined in your unit test and display them right here. And these are, of course, the names that you've given to your unit test. So you can play around a bit with that. If the students fail an individual unit test, they'll also find an individual error for that specific unit test there as well. Now, some unit test frameworks allow you to also specify messages and error messages. So definitely play around with that if you want. So this is now it. A really easy Python assignment, just a couple of steps to set up some input and output tests where we check the whole program, some code quality steps where we check the style of the program, and also some unit tests. And it just takes a couple of minutes. And what's nice now is that if we have another assignment, we can really easily just import this auto test. We can leave the code quality. We can just replace the test Sudoku fixture here, and we can maybe edit, or for sure edit some of the IO tests. And that makes the whole process of creating these assignments that look a little bit similar very easy. So if there's no more questions about the vanilla Python part, I'd like to move on to the Jupyter Notebooks part. All right, cool. So for the Jupyter Notebooks, there's a couple of things we can do. And as I said in the beginning, first we'll look into running a Jupyter Notebook. The second step will be to use the IO tests to check individual variables or individual functions in a Jupyter Notebook. And finally, I'll briefly mention the unit testing framework that we are developing for Jupyter Notebooks and how you can get access to that. So first of all, to run a Jupyter Notebook, and this is important since if you hand in a Jupyter Notebook as a student, you are handing in a certain state of a Jupyter Notebook, which means that it isn't necessarily the last or the final state of the Jupyter Notebook. So what you want as a teacher is to always have that final state or a run state of the Jupyter Notebook to see if it actually works. For that, we can just use the simple Jupyter command, which is also installed by default in Autotest. And we can use the nbconvert option to execute and to convert it to a notebook. And what we can do here is use the AT output variable, which will create a new folder in our files hierarchy and have the output of your Autotest available there. So we write it to the AT output folder and we call it Jupyter.ipython notebook. And here as the input, we say we want to have the student Jupyter IPython notebook. And we specify allow all errors since we don't want this to crash if there is a syntax error, but we want to continue with the next cells if there is. Let me show you an example of this, where you actually can see what I mean as well with a state of the Jupyter Notebook. So what we have here is we have a student that has handed in a Jupyter Notebook, which is in this current state right here. So as you can see, it all works pretty well, and it looks to be a valid notebook. But then if we run it, and if we look at the auto test, then we can see that they actually have handed in a old state of this notebook. And if we look here, they are having a lot of errors in their notebook. So it's always a good way to verify a student notebook and to run it and to see a run version in Autotest. Now, of course, this is manual grading. So this is something you do in the Autotest so that once you manually grade your Jupyter Notebook, you can automatically have this folder right here generated for you, and you can use that to assess the notebook manually. But what we can also do is auto-grading. And for that, we use 3 steps. So first, we have to convert the Jupyter Notebook that was handed in to a regular Python script. And what we can then do with that regular Python script is we can import it and open it in the Python interpreter. And with that, what we can do is we can access individual variables that the students have defined. And we can also assess and run specific functions. So for instance, if you provide your students with a Jupyter Notebook where they have a template where they have to fill in certain questions. For instance, here you define a question 1 variable, for instance. You can really easily check those questions in the IO test. So you say Amazon bestsellers, which is the name of this file, question 1. And you can say right here, they define a function, or you define a function and they have to fill it in. And you can, in the IO test, you can run the function by just calling the function. And what's nice about this, since in the IO test, you are actually inside the Python interpreter, you can also do other Python arithmetic. So for instance, here we have a is 1 plus 3. And we can actually use that variable inside our function as well. So with this, you have a little bit more flexibility, and it almost acts like some sort of unit test. So the steps for this are really easy. So first we have to convert the Python notebook to a regular Python script. We do that in our category using a run program step. And we can say Jupyter nb convert again, and this time to a script. So not a notebook like we did with the run last time, but now we want to convert it to a script. And we provide the notebook that the student has handed in. So in this case, Amazon bestsellers.ipython notebook. Again, you can enforce that students use this name by using the hand-in requirements. And after you've converted this, what you can do in your IO test is while opening the Python 3 interpreter, so you do that by Python 3 -i, you can right away import the Amazon bestseller. So this is, again, the script that you have generated here. It just gives it the same name. And so now in this folder, there is a script called Amazon bestsellers.py, and you can import that using import Amazon bestsellers. And once you've done that, in the IO test, you can say you can now use the variables and the functions of this script, so of the Jupyter Notebook, using the input right here. So now you can access them through Amazon bestsellers dot some function, for instance, 1,4. And the expected output is here like usual. Let me show you a working example of this so you can see what that looks like inside CodeGrade. And there we go. That's it. So we have a Jupyter Notebook that we've handed in right here, which is the Amazon bestsellers Jupyter Notebook, just an assignment where they have a Amazon top 50 bestsellers list, and they do some data science with that. And we have some functions here. And right here, as you can see, we have the question 1, we have question 2 nonfiction, question 2 fiction, question 3, and finally question 4 and the sum function down here. And if we go to the auto test now, we can see that we can find these questions like this, and then compare the inputs with the actual output. And now, of course, these descriptions right here look a little bit messy since you are using the whole Python import, blah, blah, blah. But what is nice is that with the new feature we are bringing out next week, you can actually customize these descriptions yourself. So you can really nicely specify to the students which parts you are grading for each of these steps. And that makes this very easy to set up, since all you have to do is convert it and create your input-output test using our UI. And you can really clearly communicate that to the students. So that makes this, I think, a really nice method to do this. Are there any questions, Youri, about this? Nope. Great. Let me continue here with the unit tests. And so what we are creating is a script called CG Jupyter Unit, which is a unit testing framework, especially for Jupyter Notebooks, which has very similar functionality to a tool called nbgrader. Some of you may have used that before. And we are actually beta testing that right now in a closed beta. And if you would like to use that tool, feel free to send us an email at support@codegrade.com, since we would love to get your feedback on that to improve it, so we can, in a couple of weeks or months, bring that out to everyone in the auto test image. So to just quickly compare this unit testing method with the I/O tests, I think the I/O test is by far the easier method, since you can do everything in our UI. And of course, always unit testing could be a little bit error prone. But if you would like to do it, there's a couple of benefits to unit testing. Of course, you can better interpret more advanced data types. So the input and output testing is somewhat limited to lists or individual strings or integers or floating point numbers, whereas with a unit test, you can compare any data type that you want. For instance, a matplotlib or things like that. Things like NumPy arrays or data frames do work really well with I/O tests as well. So for most data science assignments like this one, as we can see right here, we are actually checking a array right here. And this works pretty well. So we can just copy and paste the array in here. Now, of course, if you need unit testing functionality, so for instance, testing exceptions or things like that, that's something you cannot do with I/O test. Also, trying to use random input and output is also something that is better done with a unit test. So think about it. If you want to use it, feel free to let us know, and we'd love to help you out with that. So let me now finally show you some other things that you can do to grade both Jupyter Notebooks and Python. And most of the things I'll show you here also apply to other languages like Java or C or JavaScript. So a request we actually got from Greg, who's also in this call here, is that he has a course and he wanted to check for a specific structure. And we get that request more often, that teachers want to see if students are using the right conditions or the right loops, or they are importing the right package or things like that. And of course, those things are generally pretty hard to automatically assess, since students can always find a way to kind of cheat your tests. Now, we found a tool looking into that called semgrep, which is an excellent tool which can be used to find, or well, it's called semgrep, so semantic grep, to find individual structures in code. And it works very well with Python code. And what we've done is we've created a wrapper script around this that's also in closed beta and can be used. And it works kind of like a unit test. So what you have, you upload it as a unit test, kind of similar to what I showed you with CG Pytest. And all the individual tests that you've given, or all the individual structures that you want to match, are individual tests in your unit test. So for instance, with this example here, we have an introductory course where we want the students for this assignment, we want to teach them how to use a for loop. And of course, we had while loops before, and we don't want them to use a while loop instead of a for loop for this assignment. So what we have here are two tests. One is a for loop, and one is a while loop. And we want to check if there is a for loop, and we want to check if there is no while loop. And to do that, we created a test right here, which is a very simple YAML file. And this is a semgrep file with some differences. And let me just quickly go through this file with you, so it could be really easy for you to replicate. So semgrep, you create rules. And in this case, we have two different rules, one for the for loop, one for the no while loop. And each rule has a pattern. And in this case, for the for loop, we are trying to match a for loop. So we say for, which is Python, and then we have this EL variable here. This is a meta variable, and this just parses something that is there. Could be anything. And then we say in, and then we have another variable, kind of like a wildcard, and which is the LST variable here. And then, of course, the Python syntax ... with a double dots. What is that called? Double dot? No. Then underneath that, the block. What, sorry? Colon. Yeah, of course. Thanks, colon. And then, of course, the content of the for loop, the block of code, we can just use these 3 dots, the ellipses, and this will catch anything as well as a wildcard. And actually, this can have as much code as you want. So with this here, we catch any type of for loop. And we have this message right here, a for loop was used. And this is the message also that we use in the unit test. So as you can see right here, a for loop was used. This is what we will print to the student. And then finally, the severity info, that's fine. And languages, Python, since we're using this for Python. Now, for the while, we do something similar. We just say while, and then again, we have the condition here, which is again a meta variable. These names are arbitrary, so you can use any name here, but these just catch something there. And then again, we have the colon, and we have the ellipses here, which will catch anything that's there. So as a wildcard, it can be multiple lines, it can be 1 line, it can be nothing, as long as this is there. Now, one thing that is not present in semgrep, but something we've added to the CodeGrade semgrep version is the match expected field right here. So with the match expected field, what you can do is you can say whether you expect a match or not. Pretty self-explanatory. So in this case, we do want a for loop. So we say match expected is true. And for the while loop, since we do not want a while loop, it would be negative. It would be an error if they use a while loop. We say false. So with a regular semgrep, by default, all the matches that you have are negative matches. So they're mistakes. And now with this one, you can also enforce things and have positive matches. So as you can see, you kind of got to get the hang of it. But in essence, all you have to change are the pattern, the message, and the match expected. And with that, you can really easily try to detect structures in your code. What's really nice about semgrep is since all it is about is this pattern, is you can go to semgrep.dev, which is the website, and you can find the right section right here. And you can actually check your custom patterns right here and see if they work on some code that you add here as test code. And after that, you can port it to CodeGrade. And this is really intuitive. I played around with this a lot while writing the blog, and this will really help you out. So the languages that semgrep supports are, of course, Python, but also Go, Java, JavaScript, Ruby, and C and PHP are in alpha version. But I've read that they're actually pretty far with those as well. So to get this work inside CodeGrade, all you have to do, and this is a very similar workflow as it is with the Pytest one, you have to upload your tests.yaml and the CG semgrep as a fixture. So of course, CG semgrep, as it is in closed beta right now, it's not on the image by default yet. But in the future, this will be on the Autotest image, and you don't have to upload it yourself, and you can just use it. Again, if you want to use it, reach out to us at support. Now, after that, you have to install CG semgrep. So you can do that by saying sudo fixtures CG semgrep install. And again, since we uploaded this as a fixture, we have to add the fixtures folder before this, and then run it as a unit test. And that is very similar to the one that we had before as well. To show you this in practice here, and I have an assignment ready for you. Now, I've uploaded a file now that does not contain a while loop, but it also does not contain a for loop. So as you can see here, we get the error, a for loop was used, expected to find a match, but none was found, and no while loop, we get a check mark there. Now, if I upload something here again as a test submission, which has a for loop in it, and for that I'll go to sort, bubble sort here, submit, and now what we'll see is that it will find the for loop, since there is a for loop in here, even the double for loop, and but it will not find a while loop, so we get a 100% score here. So let me wait for this. Again, Youri, this is a great time for questions.
Yeah, so we had a question about, like, is there anything we've noticed that can't be detected very easily? So
yeah,
I don't know. So my answer was like, if you want to go like more advanced structures and find out where something is in the code, that's more difficult, of course, a lot more difficult, because it's just trying to find it somewhere and not really at a specific location, right?
Yeah, correct. So I think for that, semgrep does have maybe some tools. So there is a lot of different fields as well that you can use inside semgrep. So it could be that there is a field for that. But other than that, semgrep is really, really versatile. And you can find examples of semgrep patterns on semgrep.dev/explore. And you can find examples here. And as you can see, some of these examples are pretty cool and a little bit more elaborate. So there is a lot possible with semgrep, but from what we've tried is mostly simple for loops, if statements, things like that. But also, for instance, if people use a default library that we don't want to use. So what's nice about semgrep is that it will automatically expand a full, I forgot the name for that, but let's say right here, we're using the JWT.sign. And let's say you change the name of JWT, it will still find this as it's looking for the real path of things. Or if you use another import statement or rename a variable in Python, let's say you import numpy as, it will all fix that for you. So it really adds a lot of functions that make it really easy to find specific things in your code. And as we can see here, it now found both a for loop and it didn't find a while loop. Was there any other question, Youri?
Not really, but not really that I can answer right now.
All right. Yeah. Yeah. semgrep is a pretty elaborate tool. So I'm by no means an expert in it after experimenting with it for a day. But it really has a lot of possibilities for education as well, especially with the CG semgrep wrapper that we've created. So you can also have these positive matches. So before we end, I want to share one little snippet with you, which has helped me a lot and also helped some of the teachers I work together with a lot. And that is to import Python code without printing. So if we think back of the way we use the Jupyter input and output checks, we, of course, converted a Jupyter Notebook to a Python script, and then we imported that Python script in our Python interpreter. Now, if a student has a print statement in that Python script, that will all get run once you import it. Since once you import something in Python, it will just run everything. And of course, this will clash with your input and output match, since they're probably printing something that you're not expecting in your input and output match. So what you can do here is you can use this little snippet right here to import Python code without printing. So we use the context-lib package for that, or the library, and we import the redirect std out. And with the standard output redirected to none, which can be compared with def null, we can now import the script that we want. So in this case, again, it's the import Amazon bestsellers. And what's nice now is that since we are importing this with the standard output to none, none of the standard output will be printed inside CodeGrade. So it cannot interfere with your input and output checks. After that, of course, all the things that you print out in your interpreter will be printed out again. So this only applies to the import statement right here. And how we use this is we save this as the import without print Python script. We uploaded that as a fixture. We move that to the current directory. Again, steps that we've explained before. And then in your input and output test, instead of importing the Amazon bestsellers directly here, we say from import without print, import star, so import everything. And this will replicate how it would be with just importing the Amazon bestsellers. So this is something you can use for your IO test as well. Great. So this was everything I wanted to share with you about Python. Of course, there's so much that's possible with autograding Python in CodeGrade. Since you can install anything, you can use any package. So this didn't explain anything or everything that you could do. But hopefully it could give you a good insight into what's possible, and also a little bit of good practices and workflows for creating your auto tests. If you have any questions, please do not hesitate to email us at support@codegrade.com. We're always happy to help you. And if you have any requests, like right now with the structure, for instance, we're always also happy to research these things together with you and help you out with that as well.